Okay, today we're going to look at finding the arc length of a smooth curve and the calculus that we're going to use to do that. So to help us to go up with this, because our arc length, that's the length of the curve, let's go back to our distance formula that you learned in geometry class. So remember, distance is the change in your x's minus plus change of your x's squared plus the change in your y squared. Now I'm going to do this as x1 minus x1 minus 1. So these are very infinitely close x's and infinitely close y's, what we're going to do. Now notice in calculus notation how we can write that change in the x's is delta x or dx squared, and the way we write the change in the y is delta y squared. So we have the square root of delta x squared plus delta y squared. Now, to help us kind of do some algebra with this, I'm going to multiply by 1. So I'm going to choose to multiply my second term, delta y squared. I'm going to multiply this by 1 in the form of delta x squared over delta x squared. Now, the reason I did that is so that I can now rewrite the second term as delta y squared over delta x squared times delta x squared. So I moved that denominator to the denominator of my first term in that multiplication, because the order of operations multiplication doesn't matter. Now I can factor out my GCF of these two terms, which is delta x squared, and I can factor that out. Now the square root of delta x squared is just delta x. I'm going to bring that out of the parentheses. Then I ask myself, okay, I have the change in y of the change of x quantity squared. Well, what is that in calculus notation? Well, that is simply our derivative of y with respect to x. That's what that is. So basically, our formula to finding a length of an arc starts with this formula here, that our arc length, s is the symbol they use for arc length, that's lowercase s, is equal to the square root of 1 plus delta y over delta x quantity squared dx, and we're going to integrate that from a to b. So we're providing that arc length for all sections of this. So the integral from a to b of the square root of 1 plus the derivative squared dx. So that's the arc length formula we're going to use. So in words, this again is the integral from a to b of the square root of 1 plus our derivative squared, and then dx. It could also be, of course, our derivative can be in y, and then we'd use dy. It just depends on the situation. So let's look at our first example. We're going to find the arc length of the graph of y equals x cubed over 6 plus 1 over 2x on the interval from 1/2 to 2. First thing I got to do is I need to find my derivative. So I know y is equal to this equation. I'm going to bring out that x cubed, rewrite my x to the negative 1 here. And then, so I'm going to just find the derivative of this. So that gives us 3/6 over x cubed minus a 1/2 x to the negative 2 power. So just simplifying that down. And if I wanted to, I could also factor out my GCF here to get this expression. So that's my derivative function. So now I'm going to find my arc length by taking the integral from 1/2 to 2 of the square root of 1 plus my derivative, so that's that 1/2 quantity x squared minus 1 over x squared dx. Okay, got to do a little algebra in this section, so we're going to need to rewrite this. So we're going to do a little algebra work. So I'm going to get rid of my square. So 1/2 squared is 1/4. And then if I square this, doing the full method, I'll end up with x to the 4th minus 2 plus 1 over x to the 4th. Next thing I'm going to do is I'm going to look at this and say, okay, let's factor out a 1/4. We're still underneath the square root here. And if I combine, so I can rewrite that 1 as 4. When I factor out the 1/4, combine my like terms, happen to notice that that parentheses term is a perfect square. So I'll rewrite that as a perfect square, a perfect square. So I can rewrite this as an integral of 1/2 to 2 of the square root of 1/4 of x squared plus 1 over x squared, quantity squared, dx. Now we're ready to integrate. Well, no, let's not integrate that. So let's take the square root of 1/4, which is half. The square root of the parentheses term is just the square root and the square cancel each other out. Now we're ready, finally ready to integrate. I'm going to factor out that 1/2. And then the integral of my parentheses term, that's x cubed over 3 plus 1 over x. And we're going to integrate from 1/2 to 2. So plugging in the 1/2, I'm running out of room, so I'm just going to do this and write it down. So that's 13/6 plus 47 over 24. And then combining that together to end up with our final answer, arc length is 33 over 16. I just want to remind you of that one thing I did back here when I had that, I made a perfect square and I made a binomial squared. This process of making something into a perfect square is something you'll use a lot in this skill, mainly because we've got the square root, and if we have a square and a square root, we'll be able to cancel those out and work with it. So think about that if you ever get stuck and the u sub doesn't work for that situation. Okay, we're going to find the arc length of this graph. So our y is equal to natural log cosine of x. So again, we need to start by finding the derivative of this function. We're going to use the chain rule. The derivative of natural log is 1 over cosine of x in this case, times by the derivative of the inside, which is negative sine of x. And then we know that negative sine of x over cosine of x is simply negative tangent of x. Now we're going to use our arc length formula, so we're going to integrate from 0 to pi over 4 of the square root of 1 plus our derivative, which is negative tangent quantity squared, so that's going to end up being positive. And then we know from trig that 1 plus tangent squared is secant squared, and secant squared and the square root cancel each other out, so we're left with secant of x. You notice how we use some of our trig formulas to help us out? You'll need to do this. And then recall that the integral of secant x is the natural log of the absolute value of secant x plus tangent x. And then we're going to, of course, evaluate this from 0 pi over 4. So plugging in pi over 4, we know the secant of pi over 4 is the square root of 2, and the tangent of pi over 4 is 1. And then minus plugging in 0. So secant of 0 is secant plus tangent of 0 is 1. So we have the natural log of 1. So that is our answer. Or if you want to, you can touch it into your calculator and get 0.881. Usually we leave it in the exact answer form. So that is our arc length formula.